Okay, so I would like to do number 8.2, or sorry, number 3a in 8.2, which is inverse Laplace transform this nasty looking fraction. Because, yeah, that's the category of thing you're going to inverse Laplace transform. You're going to get a nasty looking fraction. Let's get some practice getting rid of them. So, to head back from Magic Land, how do I do this?
If you split it up, you can, on the second term, you can get rid of 2 of the factors.
Okay.
Like.
Yeah. I'm definitely with you, except that I'm definitely not going to do that. And the reason I'm not going to do that is if you do so, it's actually, yeah, I feel bad because I'm telling you this is a terrible idea. Because it was like, that was a really good observation. It's just a really bad idea. So, if you did that, you would get 3 over all, like, 3 terms of this stuff, right? Right? Mm-hmm. And then you'd get a minus 1 over, what, s plus 2?
Yeah.
Okay, so this part, check, done.
Cool.
This part,
gross.
You got to do partial fraction decomposition on this anyway.
So
You guys see that?
Might as well start with partial.
So you may as well just do partial fraction decomposition over there, because you're going to have to do it anyway. You guys see that? Like, okay, I said it was a terrible idea. It's merely an inconvenience. Also, if you have something that's got a couple of factors up here in it that agree with the factors down here, that Heaviside method thing is really fast. So like if you notice this, you can just slam it up. In fact, it would take me less time to just do it. So, I think you got this. That's the top on the left-hand side. Right, and you're, okay, I'll write this one all the way out. After you've done a couple of these, you can skip some of this writing out stuff. So I've got top, bottom, and I'm supposed to decompose this into
A over s minus 1.
A over s plus 1 plus b over s minus 2 plus c over s plus 2. Okay, why am I getting away with a, b, and c's instead of as plus b's? Yeah, they're not irreducible quadratic factors. You guys remember that about partial fractions? So this is 3 distinct linear factors. And so you can break it up into constant over linear factor 1 plus constant over linear factor 2 plus constant over linear factor 3. If they're repeated, you have to do some weird rigmarole. If they're irreducible quadratic, you have to do some different rigmarole. And if they're repeated irreducible quadratic, you have yet more different rigmarole. Okay? We'll go through those. But so, then what?
Multiply both sides by the big bottom right.
Yeah, like basically make a common denominator, right? So you do, okay, so I got 3 minus the quantity of s plus 1 times the quantity of s minus 2. That was supposed to be 1. And then this is going to equal a times s minus 2 times s plus 2 plus b times s plus 1 times s plus s times s plus 2 plus c times s plus 1 times s minus 2. Okay.
By the way, 0 sleeping when happens to pop out.
Yeah, so close. Evaluate at
Whatever makes that
A is 0, then B is 0, then.
not A, B, and C are 0, but try to make each of the linear factors 0.
Okay.
So I'm going to take this whole thing,
Something that makes.
which I'm going to
Go
call
away.
Bill. So take Bill, evaluate at s is -1, right? So I'm going to get 3
Oh.
You see how slick that was? That's why I left those in there. So you get 3 and 0 and 0. So I just get A. Right? And I get A times minus 1 minus 2 is
-3.
-3, I think. And minus 1 plus 2 is 1, pretty sure?
Yep.
Oh, cool. So
A is -1.
A is -1. Check. Then you take Bill, evaluate at
This is 2.
S is 2. So you're going to get 3 is, let's see, 0 and 0. So you get B then times 2 plus 1 is 3 times 2 plus 2 is 4. Cool. So you get B is a quarter. And then C is the hard one, right? I mean,
A little bit.
a little bit. So you take Bill and evaluate at, where haven't I evaluated at yet?
S is -2.
S is -2. Okay, so you get, oh crap, I don't get 0 on either side. Or 3, I mean, bummer. So I get 3 minus
-1 times -4.
-1 times -4. Yep. And on the other side, you get 0 and 0 and C times -2 plus 1 is -1. -2 is -4. Okay, so let's see. That's 3 minus 4 is -1. Pretty sure? And over here I got 4C. So it seems like C is -1/4. Cool. So you take all 3 of those, boom, 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 and walk back over here. Dumping everything except my coefficients. So I'm doing partial fraction decomposition, right, to the argument, and I'm going to get that thing that I started with is the inverse Laplace transform of this, where I put in A is -1, and B is a quarter, and C is -1/4. And I'm going to be like, yo, dude, this part with the S plus 1, that's an e to the minus t. This part with the S minus 2, that's a
E to the 2t.
e to the 2t. This piece with the S plus 2, that's an e to the minus 2t. And I'm going to say, slap this with table and linearity. Right? And I'm going to get minus e to the minus t plus a quarter e to the 2t minus a quarter e to the minus 2t. Wham bam.
And would this still be the answer to second order, maybe? It could be, huh?
Certainly
if
could be.
it wasn't a 0 forcing.
Yeah, so I don't know. I didn't construct this that way. But yeah, this could be the answer to a second degree non-homogeneous equation. Or it could be the answer to some really gross crap, because you can actually do Laplace transforms to things that are nastier than the ones we've looked at. Right? Like if this was just another method to solve second order differential equations, I wouldn't really be spending this much time on it, because given your test scores, you guys are badass at that shit. Right? So this thing applies to more stuff, basically. Cool.